Everyone, welcome back to our YouTube channel. Myself by-A.N.Rath. I am here today to discuss about the fundamental of gears. This is the second lesson on gear. In the first chapter, we have discussed about the gearbox, especially the mill gearbox, planetary type gearbox. And in this session, we'll discuss about what is gear, the basic fundamentals of gears, classification of gears, what are the application of gears, and many more things. So let's discuss about gears. First, we'll discuss what is gear. Basically, gear is a cylindrical element which is used to transmit the motion or power by means of progressive engagement of the teeth. So you see here the definition is gear is a cylindrical machine element used to transmit motion and power between the rotating shafts. One shaft is attached with the motor, that is called the driver, and another is attached to the equipment which needs to be rotated, that is the driven gear. So the gear is a cylindrical machine element used to transmit motion and power between rotating shafts by means of progressive engagement of the teeth. Gear comprises of number of teeth. You see from this figure there is a compound gear. Why it is called compound gear? Because in this gear assembly there are two gears mounted on one shaft. You see, in a single shaft there are two gears, so it is called compound gear. And this compound gear is attached with the motor. When it rotates, it transmits the motion, transmit the rotational power to the output gear. And the best thing is here the direction of rotation, if you see, of the compound gear and the output gear are in the opposite direction. So why gear is used for? Basically, gears, we are using the gear for either change of speed or change of torque or for the change of direction of power source. So see, by using the gear, we can increase or decrease the speed of the output gear or change the torque. It may be increase or decrease, and also we can change the direction of the power source by using the worm gear, or you can see the bevel gear. We'll discuss in the next slide about this, how the direction of the power source changes by using the gear. So basically you see from this figure, A gear is the driver gear and B is called the driven gear, because the A gear is attached with the power source, from where first this shaft will rotate, and along with the shaft the gear will rotate, and further this gear, as it is attached to the driven gear, it also transmit the rotational motion to the driven gear. And here you can see the direction also. A rotates in the anti-clockwise direction, whereas B rotates in the clockwise direction. See, now in this figure there are three gears attached to each other, and such type of gear assembly is known as gear train, or you can say gear mesh. So here you see the direction of rotation of the gear A is same as the direction of rotation of gear D. So in any gear train, the odd number of gears direction is same and the even number of gears directions are same. And from this gear assembly, if we know the number of teeth and the speed of any gear, we can easily calculate the speed and teeth of other gears also. So the basic key element of selecting a gear is the gear ratio. Gear ratio is nothing but the speed of the final gear, that is the output gear, to the speed of the input gear. Whatever may be the intermediate gears available in between the input and output gear, the gear ratio is the final speed of the gear, final gear speed to the initial speed. So in any gearbox, as we know the speed of the motor, that is the input gear speed we know, and whatever the gear arrangement is there with the input gear, the number of teeth if we know, and we know the speed of the pump which is attached to the motor, so we can easily calculate the number of teeth required for the output gear here. So now we'll discuss about the application of gears. You know, in our daily life, application of gear is huge. You can take the example of a simple wristwatch. Whenever you open this wristwatch, you see there is a gear mesh. It comprises of number of gears. The application of gear is basically in the gearbox first. Wherever there is a rotating equipment, wherever in the automobile section also you see the application of gear is very much, and in the rotary equipments used in the industries, mining, earth moving equipments, marine sectors, lift, and conveyor system used in the CSP, ash handling system, and other areas, cement plants. You see watch, wall clock, and switch gear. It is used in the electrical breakers or machineries. You see, what do you mean by switch gear? It is a combination of switch and gear. So that's why it is named as switch gear. So gear are also used in the switch gear mechanism. And you see, in industrial robot also gears plays a vital role. And basically in nowadays in shipping, in marine, you see, and in any process industries, gear plays a major role from material handling to processing to packaging and forwarding. You see from this figure how the material move from one place to another place by means of conveyor system. So gear in nowadays plays a vital role in most of the equipment. Now we see the classification of gears, because as we know there are different types of gears. So we first see the classification of gear. As we know, the spur gears, helical gears, bevel gears, ohm gears, there are different types of gears, but based on the axis of the shaft, gear basically classified as three types, that is parallel axis gears, intersecting axis gears, and non-parallel and non-intersecting type. But in parallel axis gears, basically the axis of both the shaft are parallel to each other, and in intersecting, both the axis of the gears will intersect with each other, maybe at 90 degree, maybe at some other angles we'll see. And in non-parallel, non-intersecting means the axes are not parallel or not intersecting also. We'll see some examples of such type of gears. If you see the parallel axis gear, you see the spur gear, helical gear, double helical gear, and the herringbone gears. And you see here in the spur gear, the axis is here, and here the axis is here. And these two axes are parallel to each other. Here in this helical gear arrangement, you see this is one axis, this is one axis, and these axes are also parallel to each other. So now you see the intersecting types. Intersecting types are straight bevel, It may be spiral bevel, maybe gerol gear bevel, or face gears. So we'll discuss one by one in further slides. We'll see in this bevel gear arrangement and this spiral bevel. You see here the axis. If we see the axis, this is the axis of one gear and this is the axis of another gear. It intersect each other. In second arrangement, you see this is one axis and this is one axis, also intersect with each other. So this is the second classification. And the third classification, you see the example of those gears whose axes are non-parallel, non-intersecting, or the spiral type or hypoid type or worm gear type. You see this is the arrangement of one worm gear type. Now we'll move to the further slide where we'll see what is helix angle, because this plays a very vital role in the gear manufacturing. Because in the next slide we'll discuss about the gears having zero helix angle, and basically the helix angle of any gear varies between 0 to 90 degree. And in this arrangement you see the teeth, this is the axis of the teeth, these are the axis of the tooth, and this is the axis, shaft axis, and the angle here is the helix angle. This is known as the helix angle basically. So the helix angle is the angle between the gear axis and the imaginary tangent of the tooth, and as I said, this varies between 0 to 90 degree. So now you see this is a spur gear. Why I say this is spur gear? You see the teeth here. The teeth of the spur gears are straight. It is having no helix angle. And the best part of the spur gears, the characteristics of spur gears are it is very easy to manufacture as there is no helix angle. And it is the very most common type of gear, very common type of gears with a very high efficiency. However, the demerit is, the disadvantage is, when it operates, it normally produce high noise if compared with the helical gears. Why? I'm just explaining here. See the teeth. If you see, this is the teeth projection. If you see, this is the teeth, the length of the teeth, and here you see if there is a helix angle, the teeth will be like this. For the same profile, the teeth will be like this. Then the distance of this spore teeth, and this is the helical teeth, because it has some helical angle. I will explain in a next slide how, what is the angle here. So this distance is more than this distance is more than this distance. So in helical gear, what happened? The contact is more in comparison with the spur gear. So as the contact is less in the spur gear, the noise produced in the spur gear is slightly higher than the helical gear. So now we will see the spur gears are easy to manufacture. It's the most common type of gear with high efficiency. Its shafts are parallel to each other. You can see from the picture here, and the teeth are straight, having no helix angle, and the noise produces more in comparison to helical gears. And the best part is here, you see the force. The force applied here, if you see, the axial force is 0 and there is only a radial force. So this is all about the spur gears. Now you see helical gears. You see, in this helical gears, this is the axis of the shaft and this is the axis of the teeth. See, these are the axis of the teeth. And you see, there is an angle. So as I said, if we compare it with spur gears, then the noise in this gear is less because the contact, the blue pattern is more in comparison with the spur gear. So now see, this is complex manufacturing because as there is an helix angle, the manufacturing process is also slightly complex. And here you see the shaft are, though the shaft are parallel to each other, but the teeth inclined and making an helix angle which varies from 0 to 90 degree. And here the surface contact is more. I have already explained in the previous slide, the contact is more, so it can take more load. As the contact is more, it takes more load and can provide high strength due to longer tooth, because for the same thickness, you see the thickness, this is the thickness of the gear. For the same thickness, if I draw the spur gear, the length will be this much. If we see the helical gear, the length will be more. So here what happened is the length is more, the contact is more, hence it can take more load. And one best part is, as there is a helix angle, the helix angle may be of two types. It may be left hand type or it may be right hand type. We will discuss in the next slide about that, about the helix angle types. Now, as I already said, the noise produced in the helical gear in comparison to spur gear is less because the contact is more. As the contact area is high, the efficiency is less. So the spur gear efficiency is higher than this helical gear because here the contact is more, so friction is more, so there is a loss, so efficiency is less here. But in this arrangement, in comparison with the spur gear, in the spur gear we have seen that the axial force is 0, only radial force acting on that, but here both axial and radial force acting on the gear teeth. You can see from this, the axis, from in the direction of axis also we are having some force, and in the direction of radial direction also we are having some force. So now we'll discuss about the helical gears, helix, hand of helix, which is the, as I said, that may be left hand type helix or right hand type. Just see the difference. In this picture, you see the tooth profile. You see the tooth profile is like this, and if progressively we see this tooth profile is slightly left, slightly bending towards the left, so this is the left hand helix, helical gears. And if we see the right hand type, see here, the tooth profile, you see this is slightly inclined to the right, so this is the right hand helical gears. So now we see the types of helical gears. We have already discussed about the types of gears, but here we discuss about the type of helical gears. So it may be single helical gears, it may be double helical gears, it may be cross helical gears, or it may be herringbone. So I will show you some pictures in the next slide. These are the types of helical gears: single helical, double helical, herringbone type, or cross helical or screw gears. So basically, in single helical gear, if you see, the axis of shaft in single helical is parallel, and in the cross helical gears it is non-parallel. From the photos I will show you in the next slide how it is, the how the axes are parallel and non-parallel in case of single helical or double helical gear, and in case of cross helical gears. And axial force is generated due to forces applied in between the mating gear surfaces here, because radial force anyhow, as there are the contact of two gears, the two shaft will give the radial force to each other. But if you see the axial force, how it will impact, then the axial force basically transmit from one teeth to another teeth. So let us see in the next slide the photographs of the helical gears. See, this is a single helical gear, and this is a cross helical gears. As I said, in single helical or double helical gear, you see the shaft is parallel to each other, and in double helical gear, you see the shaft is completely parallel. It is in one single shaft. But in case of cross helical gears, you see the axis intersect with each other. And in herringbone type gears, you see two numbers of helical gears just join together without any axial gap. Here you see in this double helical gears there is a axial gap, but here you see there is no axial gap. So if anybody will ask what is the difference between double helical and herringbone gears, herringbone gears are double helical gears but having no axial gaps. And the best part is here you see in double helical gears the axial force whatever exerted due to the both the axes, it just nullify each other. See, in herringbone gears, the gears are joined together without any axial gap, as I said. Whereas this gap between, there is a gap between double helical type gears. But however, in herringbone gears and the double helical gears, the net axial force is zero, because due to the arrangement. Because from this arrangement itself, whatever the axial force exerted by one gear will cancel out the axial force exerted by another gear. So now we move to the bevel gear section. Bevel gear basically used in the planetary type of gear where there is a change of direction of the power source. See, this is an arrangement of bevel gears. This is a spiral type of bevel gear. This teeth is spiral in nature. If it is straight in nature, we can say straight type bevel gear. So we'll see the classification of gears. So here the manufacturing of bevel gear is really very complex due to the conical shape. You see the face of the gear are conical. Just see this one and this one. This is a cone type. Here this also this type. If I draw another, so you see if there are teeth and this is conical type. So here the face of the gear is conically shaped, and hence the nature of manufacturing is very complex. and the shaft is also intersecting with each other. You see, this is the shaft axis and this is the shaft axis, so they intersect with each other. Now you see, its tooth may be straight. If it is straight, we can say straight bevel gear. If it is helical in nature, here as in the picture, it is known as spiral type bevel gear. And noise produced in the bevel is much more less in comparison with the spur gears. But if we compare the straight bevel and the spiral bevel, then the noise produced in the spiral bevel is much more less in comparison to the straight bevel. As we know, in straight type teeth, the contact area is less, so the noise produced is high. However, the efficiency in the straight bevel type gear is more in comparison to the spiral bevel, because the contact is less, and as the contact is less, there is a less frictional force, so the efficiency is more. So now you see, in such type of gear arrangement, axial and radial, both the force exert here. So now you see the type of bevel gear. We'll see the bevel gear may be classified as straight bevel type gear, where the tooth profiles are straight in nature. It may be spiral type bevel gears. It may be gyral bevel gears, or it may be hyper bevel gears. We'll discuss one by one. You see, first, in all the bevel gears, the pitch surface is always conical in nature, as I already explained in the previous slide. You see, this is the straight bevel gear. Here, the teeth profile, you see, the teeth profile are straight in nature. See, these are straight in nature. So this is known as straight bevel gears. You see the gyral bevel gears. In gyral bevel gears, the best part is that though the teeth are curved in nature but having no helix angle. If you see the helix angle here, the helix angle is 0. This is the difference between spiral bevel gear and gyral bevel gear, is that gyral bevel gear tooth are curved in nature. You see, the tooth are curved in nature, but it has no helix angle. So now you see the next one is your spiral type. In spiral type bevel gear, what happened? The tooth are curved in nature, as well as it is having one helix angle. Now you see the hypered bevel gear. Hypered bevel gear are similar to the spiral type bevel gear, but the difference is only one, that the pinion and the shaft axis are offset in nature. You see the axis, this is the axis, and here you see this axis and this axis perpendicular to each other, and here it is also perpendicular to each other, but the axis is not at the center. The pinion, this small shaft is known as the pinion, and this is the bevel. This gear is bevel, and here the shaft maybe somehow in if it is spiral gear, then the shaft should be here, but here the shaft, there is a offset in axis. So in hyper bevel gear, though it is similar to the spiral bevel gear, but the shaft of the pinion is slightly offset. So as I have already said, the pitch surface in all the bevel gears are conical in nature, And in straight bevel gear, tooth are straight, and in zero bevel gear, tooth are curved but having no helix angle. In spiral bevel gear, tooth are curved and having some helix angle. Normally it is around 35-degree helix angle. But in spiral gear, bevel gear, the noise is less, efficiency is also less because the contact is more and there is a friction loss. So this is all about the type of gears and the application of gears. We'll meet again in the next session with some more informations, more lessons, more topics. This is all about the gears, basic of gears or fundamental of gears. Thank you very much.